So a pretty brief agenda for today in terms of objectives. We talked about how ions form yesterday. Today we'll be using that information to create compounds out of ions, which is what the question of the day sort of introduced. And importantly, what is the proper ratio of elements in a compound? Okay, how do we come up with a compound that has the right combination of positive and negative so that they balance each other out? That's the goal for today. I'll show you the steps that we go through. I'll show you an example using those steps one at a time, step by step. And then I'll have you try a couple practice-wise, and I'll go over them with you. And then the homework or the classwork at the end of class will be to practice some more writing of formulas. So we talked a little bit yesterday, or what we talked about yesterday was that atoms can turn into ions, which have either a positive or a negative charge. And those ions, because they're opposite, will be attracted to one another. Right? Positive and negative attract. That creates a force that holds the ions together, which is called an ionic bond. What we're going to work on today is a really important part of this process, which is that the compound, once those ions get together and form those bonds, the compound overall has to be neutral. Just by way of example, if you have ever, cooked and had a pinch of salt or spilled salt and wiped it up, you don't get a shock when you touch salt. Even though the salt is made up of billions and billions and billions and billions of electrically charged particles called ions. The reason for that is that when those ions combine in the right ratio, they cancel each other out. So the compound of salt that we use in our food is electrically neutral. If you touched any one of those ions by themselves, you might feel a shock. Not one of them, but if you were in contact with many ions, you could feel a shock. So how do we figure that out? First, a little bit of vocabulary. We have to get through a bunch of these terms as we introduce the new concepts. I talked about a chemical bond and the ions a little bit yesterday, but that force, right, the positive and negative attracting each other, is called an ionic bond. It's a bond formed by the attraction between opposite ions. And not too surprisingly, and not terribly creatively, the term for that type of compound made up of ionic bonds is an ionic compound. That's what we're talking about. There are other compounds that are called covalent, but today and for the next several days, we'll be talking about different types of ionic compounds made up of ions that are held together by these bonds called ionic bonds. And then, again, just terminology, because you will see this in different worksheets or different notes that we go through. We have special names for positive and negative ions so that we can distinguish between the two without saying all the time positive or negative ion. But I'm okay if you refer to them as positive and negative. It's just that you need to know the names because you will see them and you need to be able to understand what that means. So the special name for a positive ion is a cation. Cation, not cation. It's just a cation. So when you see that term, it's referring to the positively charged side of the equation. And then negative is anion. How do you know, how can you sort of learn the difference? Well, one, there's two options, right? There's cation and anion, and you just have to remember which one is positive, which one's negative. In order to help you with that, there's a couple things you can look at. Anion has that AN prefix, which is like anti, so like an anti-ion, which has that negative connotation to it. And anti is a negative term. So anion, and again, it's not anion, it's anion, and it's not an ion, it's anion, is a negative ion. The other one that someone pointed out to me at some point, a student came up with this, is that the T in the middle of cation is kind of like a plus sign. So maybe that helps you kind of register cation as positive. Maybe you like cats, and cats have a positive connotation to you. Whatever works is fine with me. Okay, so when you see cation, that means positive, anion means negative. You just need to be aware of that for when it comes up. Again, if you refer to it as positive and negative, I'm totally fine with that. Again, worth reiterating, I've said it, seen different versions of these notes a couple of times. But the key here is that a compound is not a compound if it's not neutral, or it's not a proper compound. Okay, the ions are positive and negatively charged, but when they combine in a ratio that cancels out all the charges involved. And there's one ratio that will work. I shouldn't say that. There's multiple ratios that could work, but we always use the simplest ratio when we write the formulas. Okay, so there's one simplest ratio for every compound. And I'm going to show you what I mean by that in a minute. Okay, so I am going to show you these steps. I'm going to list them all. The first one and the last one, I think, hopefully will make sense just by the way they're explained or worded. The middle two, which are they kind of go together, probably won't make any sense at all until I show it to you, and then even then it might take you a little bit to get used to. But I want to show them all to you kind of in a list form, and then I'll go through a couple of examples step by step so you can see what these things mean. The first step is what we did yesterday. Find the charge of each ion. Okay, you're going to have positive and negative. You can look them up on the periodic table, and some of these you'll probably just get used to using and memorize that oxygen's always -2, sodium's always +1. But you can look them up on the periodic table and use the chart that I gave you yesterday to work out the charges. So that's what we did yesterday. That's step one of this process, which is why I said yesterday you want to get used to doing this because it's just the first part of the process. Now, these next two steps are the ones that may not, or I should say probably, won't make sense until I show them to you. And they're basically the same step in reverse. Step 2 is going one way, step 3 is going the other way. So we are going to use the charge of the positive ion, the cation, as the subscript, which is the little number at the bottom of the formula, of the negative ion. And then we're going to use the charge of the negative ion as the number at the bottom of the positive ion in the formula. I don't expect that to make sense yet. Hopefully it will once I've showed it to you. And then the last step is just to check that you've given it the simplest ratio. Sometimes you will do these steps in the middle, and you will get, if you do it the way I show you, you will always get a neutral compound by doing these steps. But sometimes you'll get a ratio that can be reduced or simplified, and that's that last step. So this doesn't always mean you end up doing anything, but you got to check it. Right? If you check it and it's already the simplest ratio, you can't reduce it anymore, you're done. But you got to check. So let me show you how these steps work sort of in practice. We're going to find the formula between magnesium and chlorine. And I want to point out here, just because, again, it's going to show up when you look at a worksheet or things like that. The second element in these formulas, I'll explain the naming, how we come up with the names more next time I see you, which I think will be Thursday. When we write the formula, when we write the name, we change the ending of the second element. It goes from chlorine to chloride. Right? You've probably heard of sodium chloride, which is salt. It's just the name we use. We change the ending. And that's going to be true for all these elements that come at the end of the formula, whether it's chlorine, chloride, oxygen is oxide, nitrogen is nitride, right? So when you see the IDE at the end, just kind of look for the element that has the same beginning to it, and that'll tell you which element you're looking for. But for now, we are looking at magnesium and chlorine, which when we turn it into an ion becomes called chloride. So step one is, what is the charge? What are the charges of these two ions? Well, magnesium is in group 2. All the elements in group 2 form a +2 ion. So magnesium is going to be +2 or 2 plus. Chlorine is in group 17. All of those elements form a -1 ion. So we're going to have Cl -1 or 1 minus. Now this was one of the examples I had in the question of the day. So I kind of showed you how this is going to work out. But I want to show it to you with the steps. Because this is the part that doesn't make sense until you do it. So we're going to take the magnesium and then the chlorine. And once you've done this a couple of times or a few times, you won't need to write out every single piece of this. It'll kind of just happen in your head, hopefully. If you have to write it out, write it out. It'll work. So the formula is always the positive, then the negative. Good news, bad news. Left to right, that's how they appear on the periodic table too. Left to right. In order to determine the formula, I take the charge of the positive ion. I just take the number, not the symbol. And I write it next to the symbol for the negative ion, Cl2. And I take the charge from the negative ion, and I make it the subscript or the number in the formula for the positive ion. I just crisscross the numbers, don't do the charges. Okay, so +2 becomes a 2 in the formula, -1 becomes a 1 in the formula. What that says, right, the formula MgCl2 means I have a magnesium, which is a +2 ion, and I have 2 chlorines, or chloride ions, which are each -1. Right, so just like with the puzzle, if I want a neutral compound and I start with a +2, I have to have a -2 to cancel it out. Chlorine doesn't give me -2 by itself, but if I have 2 of them and each is a -1, the total is -2. So the total charge, positive and negative, is equal and opposite. So they cancel each other out. So that tells me, and I'll show you that as a check at the end, but that tells me that I've got the ratio correct. And when you crisscross these numbers, you will always get a ratio that is neutral. But you always just have to double check. Can I simplify this? MgCl2 without fractions or decimals? Nope. That's the simplest ratio I can get. So that is the final formula. Okay, so the steps in the middle, again, are just crisscrossing numbers. Don't use the charges, just the numbers. Take the number from the positive ion, make it the subscript of the negative. Take the subscript of the negative, take the charge of the negative, make it the subscript of the positive. And then, just to show you the check, Okay, MgCl2, and I sort of explained this in the last slide as well. MgCl2, the formula means 1 magnesium, 2 chlorines. Well, 1 magnesium means a total of positive 2. 2 chlorines together gives you a total of negative 2. If the total positive charge and the total negative charge are the same, then you've created a neutral compound. And as long as you've simplified, if possible, you've got a valid ionic compound formula. So just quickly, I'll give you a couple minutes to do this. I want you to do the same thing here that I just did, except it's going to be magnesium and sulfur. So just to highlight those on the screen for you here. Magnesium we just used. Sulfur is actually over here next to chlorine, but in a different group. So I'll give you a couple minutes to look at that, figure out the charges, figure out the combination that gives you a neutral charge, and simplify if possible. And I'll show you the answer in 3 minutes.
So can you just go back to the screen that you had? Magnesium chloride.
This one?
Yeah, that's one more. Thank you. Thank you.
That's the convention.
Good to know the right.
Yeah.
Thank you.
Okay, so I just want to show you this really quickly. Magnesium in group 2 has a +2 charge. Sulfur in group 16 has a -2 charge. So if I put those together, if I do the crisscross, I get Mg2S2. Right, just swapping the numbers around. Well, a 2 and 2 ratio is the same as a 1 and 1 ratio. I can simplify that. And so the end result is just MgS. You don't have to write the 1 in a formula. If it's just 1, just write the letters. But as a shorthand or shortcut, I guess I should say, anytime you have the positive ion and the negative ion with the same charge to begin with, it's going to be a 1-to-1 ratio. Right? So if it's +1 and +1 and -1, just put them up there. Plus 2 and minus 2, same thing. Plus 3, minus 3. It happens. That could be the same thing. Okay, so anytime the charges are equal, then just write the letters. You don't even need the numbers because they're going to be a 1-to-1 ratio every time. Cancel each other out just naturally. I just wanted to show you one more, and then I'm going to let you do the worksheet. Sodium and nitrogen. Sodium's over here. Nitrogen is over here. So just to give you a different combination. Sodium is in group 1, which means it has a charge of +1, or just plus. And as I was just discussing, you'll see me write, for example, Mg2 plus rather than +2. That's technically the way you're supposed to do it. But I'm not, I'd rather focus on you knowing what the number should be rather than the convention of writing the positive sign after it. So if you write Mg2 plus, or +2 rather, that's fine. I think they do it because they don't want you to get confused and think it's magnesium plus an equation. I don't know. But like I said, if you write it +2 instead of 2 plus, that's fine. I want you to focus on learning how the charges work rather than how to write the symbols. So then nitrogen is a -3. It's in group 15, or 3 minus. So when I swap those numbers, I get Na3 and then N1, but I don't include the 1 because it's in the formula you don't need the 1. And just to kind of show you again another way, if this is a 3, that means 3 sodiums. Okay, that's what the 3 in the formula tells us, that there's 3 sodium ions in this group. And then there's 1 nitrogen in the group because the formula says N with no number next to it. So 3 sodiums, each sodium has a +1 charge. That's a total of +3. The nitrogen, 1 single nitrogen ion has a charge of -3. So that's how I end up with a neutral compound.